Hello, this is Dr. Charles Severin, and we're talking about Chapter 12 of the book Python for Informatics, Exploring Information. And now we're going to really talk about how to write programs that interact across the network. As always, this material is copyright Creative Commons Attribution. So we've been sort of working through our internet protocols. We talked about HTML, we talked about CSS. So we have our internet in the middle. We've talked about the request response cycle. And we're going to actually start writing clients now is what we're going to do. And so their client's going to make a request to a server. The server is going to process that, give us back some information. And unlike where we've been a browser before, now we're actually going to be a program as a client is what we're really going to start looking at. And so we're going to learn today a lot about the request response cycle and GET and POST and what's a socket and what's the hypertext transport protocol. So let's do a quick review of network architecture. And so if we go back to our internet discussion, we have 4 layers in our network architecture. We have the top to the bottom. The link is the lowest level that gets the data across one physical connection, maybe wireless or fiber optic or Ethernet. The internet is sort of like the worldwide post office. That is an end-to-end protocol in terms of addressing, but each router makes decisions and forwards it across. And when it's said and done, we have this transport layer that creates a seemingly perfect end-to-end in-order, error-corrected stream of data. We call it a pipe. And so TCP/IP the TCP layer built on top of IP provides us with our application can make a connection to some other application on the internet and assume that all the magic, billions of dollars of engineering below it in the transport, internet, and link layer just work. And so it's all about we've got this pipe, and so we can sort of ignore everything else and just talk application to application. And we're going to write one of these applications, and we're going to talk to a web server as the other application on the other end. And so this is basically some end-to-end connection that we can ignore the details of what's going on inside. So we call these sockets or pipes, but sockets. Socket is sort of like you plug something into the wall, and so there's some magic in between, but somehow everything works. And so the socket is our abstraction. It's an abstraction it's like a file. A file is our way to talk to the complex detail of how hard drives work, and the socket is our abstraction, our handle that we use to connect to another process across the network. So in computer networking, an internet socket or network socket is an endpoint of a bidirectional interprocess communication flow across an internet. So socket. So also to review, in addition to host names, we use port numbers. Can be thought of as phone extensions or apartment numbers. You have a building, but it also has an apartment number within the building. And it is an application or process-specific number that really identifies more closely the communications endpoint. And it allows multiple networked applications to coexist on the same server. And when we connect using that port number so that we can decide which of the applications that we want. And there's a list of well-known port numbers. So if you want to connect to the web server on www.umich.edu, you know that unless you're told otherwise, the normal port that you will talk is port 80. And so there's a list of well-known port numbers that has been evolved over time as new common applications like mail or file transfer or HTTP, the web, were evolved. They kind of sat around and decided what port number to use. And if you look at the list of port numbers, you'll find that there is sort of a historical perspective to the port numbers. The lower the number, the more likely that port number is an antique from the earliest of times. So here's an example where we have clients on the right and the server on the left, and we have a number of applications. one to process incoming email sitting on port 25, one process login on port 23, a web server sitting on port 80 and 443, and a personal mailbox. If you download your mail perhaps from Google to your iPhone, you maybe have used IMAP or POP as the way to pull that data off of the Google servers and pull it in, and they function. POP happens to function on ports 109 and 110. And again, it's just like a phone extension. It's just a way so that one IP address like 74.208.28.177 can host many different network applications, and from the outside we can pick which of those applications we want to connect with using the TCP port. So here's a list of the common ports. I mentioned Telnet. HTTP 80 is the one we'll focus on the most. Mail is port 25. POP, domain name, file transfer. Again, while it's not guaranteed, the lower the number, the more antique they are. And if you're talking and cruising around on the web and you see in the host area of a URL, colon, and then a number, what that's saying is we're going to connect our browser to a web server on a port other than 80. And so in this case, it's 8085. And it's common for developers to run test instances of applications on ports other than web applications on ports other than 80, so that the production can be on port 80 and test instances can be on other ports. So just because 80 is the convention, it doesn't mean it's always the exact port that it runs on. You can connect a web server application to a different port. So in Python, we have a powerful set of primitives, and part of the goal of Python library is to make it so that we only have to write a few lines of code. We hide all the complexity, all the IP, all the TCP, everything under as simple as interface as we possibly can do. And so, so here we have 3 lines of Python. Import socket, and then we create the socket. Now, for this line here, don't even try to worry about what the parameters are. We're creating an internet socket, and we want it to be a stream rather than a packet-based socket. But for all intents and purposes, just make a socket with exactly this syntax. I mean, you can name it whatever you want as a variable, but basically this is just like make a socket. Now the key is it actually is not connected. This socket is sort of local. It is, you created a socket to be connected. And the next thing you do is you call mysock, which is the variable that you've used to get back from the socket call to create the socket, .connect. And you give it a tuple. So this first parameter is a tuple, that's why it's in parentheses. And the tuple has 2 values. One is the host name that you're going to connect to, the domain name that you're going to connect to, and the other is the port. Now, port 80 is the normal place that you would naturally make this connection, port 80, right? So we're connecting to www.pi4inf.com, port 80. And this sort of just emphasizes that one of the goals of Python is to give us extremely powerful primitives with a library. In this case, we've imported a socket, and in the case of the famous Python XKCD comic, the person who's floating up there simply typed import anti-gravity on their Python interpreter, and here they are floating in the air. So the idea is we'll make everything as simple as possible. Like how to float in the air is simple. You just import the library for anti-gravity, and that's what makes this fun. You may or may not think this is funny, but for us nerds, this XKCD comic is an absolute stitch. So we have this socket, and so you can think of the socket basically as the socket opens up a connection to here. That's okay, I'm about ready to make a connection. And then the connect, the second step, makes the connection to the far end. Okay, and so it really is create a socket and then make the socket. And our question now is, now that we have a two-way connection between this other application, or it might blow up if there's no application there. I'll show you how that works in a sec. We have a two-way connection. How do we talk? And this is where we have to invent an application protocol. And IP is a protocol. It's a lower level protocol, and all the routers sort of know IP the same way. But the application protocols is different. They are all different for each application. The World Wide Web protocol is quite different than the email protocol, which is quite different from the Telnet protocol. But they're all application layer protocols, and you have to talk a different protocol depending on what application you're talking to on the far end. So you have to go read some documentation about the protocol. HTTP is the one we'll focus on, obviously, because it's hypertext transport protocol is the dominant one on the intranet. You know, it was invented by Tim Berners-Lee and Robert Cailloux, and they were going to retrieve HTML documents. And they were in a hurry. As Robert Cailloux says in his video, they were a small group, and they were trying to make a documentation system, and they didn't have a lot of programmers, so they made a simple yet very elegant protocol. And frankly, that's part of the reason it's taken over the universe, is that it's so simple. And of course, we've later extended it to use the exact same protocol to send data back and forth. And the protocol is extremely simple because you pretty much only have to send one line. You make a connection, which all sockets and all applications do, to a particular port. You request a document with sending a command on that connection, and then you wait and retrieve the document, and then the connection closes. Now, there's lots of sophistication beyond this, but the basic operation of the protocol is so simple that we can actually do it by hand if we so desire. So it's really a set of rules that browsers, which is the primary application that consumes HTTP, retrieving web documents over the internet. So a protocol is really just a set of conventions. In this set of pictures, I've got a left-hand steering wheel from Australia and the UK, and Japan, I think, is on the left-hand side. And then, in the US, we drive on the left side. So the top one is the US. There we go. I mean, we drive on the right side of the road, sit on the left side of the car. Whew. It's just a set of rules. It's a convention. So one of the things in an application protocol that's very important is who talks first. You establish a connection. Now, who's listening and who's talking? Because, you know, when the phone rings and so when you dial someone on the phone and their phone rings and they pick up, that's the moment that the connection has been completed. The question is, who talks first? We know, of course, what the protocol is on a telephone call. Who talks first? The person who answers the phone talks first. They always say the same thing. And what is it? Hello. And then you go, hello. So you exchange a message, and then you go, who is this? You go, I'm Chuck. Or unless you have caller ID, then you just say, you pick the phone up and say, hi, Chuck, or whatever. So we have a protocol. A phone is a good model for a connection. Right? And so the dialing and the ringing and the pickup are what the connect is. So when you grab your phone, that's kind of like the socket creation. The dialing, the ringing, and the pickup is like the connect. Once the connect is successful, you got to start sending stuff back and forth, and we have to know who's going to talk first. So that's what a protocol is. It's the rules of who's going to talk first, what are they going to say, and once they say what they're supposed to say, what are you supposed to say? On and on and on and on. So when we look at URLs, we can parse these URLs, and we look at the http:// and that is a way that we indicate which protocol to make the connection to. We have the host name, and we just parse these out with standard string operations, www.drchuck.com, and then the document that we want from that host, /page1.htm. Okay, and so if you remember the video from Robert, he's talking about the URL captures what host to talk to, what to say to that host, and what to retrieve, all in one string. It's inelegant and kind of clunky, but the fact that it's one string that captures the protocol to use, what computer you're going to talk to, and what you're asking for in that computer all in one string is actually amazingly powerful, even if it has a colon and 2 slashes unnecessarily. So when you're using a browser and you click on a link in a page, you are telling the browser to go make a connection to a server and retrieve a new page. And so in the href equals of that anchor tag, it has either a relative or an absolute URL, but in either case, it knows what host to talk to, and it issues what's called a GET request, and then the server returns the HTML document for that GET request. So let's show you an example. So we connect to a server like drchuck.com, and then we send a document request, the GET, and you're supposed to uppercase GET, so it's capital G, capital E, capital T. So the first characters you're supposed to send are GET, followed by a single space, followed by the URL of the document that you're looking for. So here we are in a browser, and we're going to click on this first link. And if you look sort of down here, you see that we're going to go to www.drchuck.com/page2.htm. And so you click on that, and the click goes to the browser, and the browser says, oh, I need to retrieve a new document. So it then, that click goes to the browser application running on your laptop or your PDA or whatever. Then the browser makes a connection to port 80 on the web server, in this case www.drchuck.com, and then sends the command get space http://www.drchuck.com/page2.htm. Server grinds through, reads the files, whatever it's going to do on its server thing, and it sends back a document in the form of HTML in this case, because we are getting a web document. And then that comes back across that socket connection. You read from the socket, and then you take that HTML, and the browser formats the HTML according to the rules of HTML and CSS, and then shows you a brand new page. So we call this the request response cycle. This is the request half, and this is the response half. Request, response. You click, request, response. Request, response. I can't really say that enough because I love the request response cycle. So let's go ahead and write a simple web browser in Python. So remember, we've got our client on the left-hand side, and we've got our server on the right-hand side, and we're going to make a request response. In this case, I'm going to go horizontal here. Request, code in the server, response. All right. Request, code, response. But now what we're going to do is we're going to be this piece of code, and we're going to rewrite this browser as in Python. Now, if you didn't have this really cool lecture and the really cool book, you'd have to go read a complex document. And that complex document would describe the interworkings of the interworkings of how HTTP works. So we'd have to go find the IETF's RFC for the Hypertext Transport Protocol. So here is an example of that protocol, and you can see that it's quite a large document. This particular one I'm looking at is a version from 1999. I'm sure there are a few tweaks since then, but here is the URL, and if you download it and take a look at it, it's of course quite a piece of work. If we go down far enough, it describes to us as what the request is, and it's a method followed by the request URI, followed by a space, followed by the request URI, followed by a space, followed by the HTTP version, followed by carriage return line feed. And so this is what we do. So we can eliminate from some servers which version of HTTP, but this is what our command to the server is supposed to look like. So we can hack this by, instead of using a browser, we can use Telnet. Telnet, right here, Telnet. So I'll show you how to do this. So this is sitting on a Macintosh. You may not be able to do this on Windows. You may have to install something to get a Telnet to work on Windows, but it works the same. You simply have to tell it to Telnet to the host you're interested in, and then add a parameter at the end, 80, which is Telnet to port 80. So Telnet will make a connection, and this is like the phone ringing, and when you see this connected, that means they've picked up. Now you'll see when we do this that it's just sitting there listening. Okay. Then we type the get command, and then it responds and then closes the connection. So let me show you how that works. Okay, so I'm sitting here in my happy little command line, telnet. Telnet to www.drchuck.com on port 80. So here we are. And so now we're talking to a web server. It's sitting somewhere in some giant hosting facility, and it's waiting for us to talk. We can type anything we want. If we didn't read the RFC, we'd be like, howdy, my name is Chuck. How are you, Mr. Web Server? And it says, bad request. Your browser sent a request that this server could not understand. The request line contained invalid characters following the protocol string. Stop doing that, right? Because howdy, my name is Chuck, how are you, Mr. Web Server does not comply with the application protocol, HTTP. So we have to go back to the drawing board, and we have to actually read what it is that you're supposed to say to this thing. Well, and so we go do that. We go read it. So now we're going to try again. And we're going to say get, followed by a single space, exactly what the specification said, http://www.doctor-chuck.com and page1.htm. I'll leave off the version number. You can put the version number on. It's http://1.0. But I'll leave that off for now. We're going to do an early. And now it actually sent us back a page. And there it is. And it's HTML. And if I telnet again, and I say get space http://www.drchuck.com/page2.htm, here we get another page. So we just pretended that we were a browser, grabbing one page and then clicking on a link and responding to that page. So if I go here, let's see. So if I go to www.drchuck.com/page1.htm, I am now, when I hit enter, saying, go please retrieve that page. So it does. Oops, let's go like this. Move this over here. So now I'm telling my browser to effectively do this. So if we were to watch the traffic, we would see this command go from my browser across the internet, retrieve the page, and bang, here's the page. Now, if I click on this, it's going to do this. If we were to watch the packets go back off my laptop, it would send that line when I click on second page. It would then retrieve and be returned this information, and that's what it displays. Okay? And so that is, each of those clicks is causing a request response cycle, or if I type a URL in here, that's going to trigger a get as well. So href causes a get to be called, and a typing in the URL box causes a get to be called. Hitting the refresh causes a get to be called. So we send a get and then retrieve the data and then display it and make it look pretty. So all the browser is really doing is, it has a bunch of rules as to how to format HTML, and that means that H1s are supposed to be big and tall, and paragraphs are supposed to do this, and links are supposed to be purple after you click on all those other rules, right? That's just how you display it. We're now talking about the protocol of how you request it and how you retrieve it. So that's hacking. This protocol is so simple, and that's, again, part of its elegance, that we can actually test it by typing parts of it by hand. Very few of the other protocols are all that simple to be tested by hand. Some of the older mail protocols, pre-security, were testable by hand, but now any of the secure protocols is just so complex. Any of the secure protocols are so complex that we generally don't exercise them by hand. So if you watch this URL, you can see one of my favorite scenes where Trinity is hacking the power grid in Matrix 2, and so you kind of see her doing this telnetting and SSHing and connecting using the exact same terminal windows that we're using. And so this is something that I find really fun to see when hacking is done accurately in the movies as compared to when it's done with some beautiful user interface screen. So if we look at a more complex web page like the University of Michigan web page, that we can telnet to port 80 on www.mich.edu. We can ask for the main page. Some browsers will take it without the URL. Some web servers, will take a GET request that only has /. We can try this one in a second. Let's go ahead and try it right now. And so telnet www.umich.edu port 80. Can't type. GET /. There we go. So if we look at this, we see we got the entire HTML of the University of Michigan web page. Okay, GET /. Now, not all browsers, not all web servers will take GET / as the sort of local version. Sometimes you'd have to say get http://www.mich.edu/. Now, the problem is deep inside here, if you take a look at this, you're going to see all kinds of images and CSS, like external style sheets. And so as we would read through this, as the browser would read through this, it would see other documents that have to be retrieved. In this case, we don't have to go very far. We see some CSSs that are being pulled in. We see some images that are being pulled in. And so what happens then is it has to make further request response cycles. So those two little page 1 and page 2.htm were fully self-contained pages. But real pages on the internet usually have quite a few links. And so you can think of it as the first, when you type www.mich.edu into your browser, it first requests the HTML, but then it has to request in some number, 15 or so other files, pictures, CSS, other things, and you can see it updating the status as it updates the status as it's pulling these things, and it assembles the web page for you. Now, it's all pretty quick usually, and some of this information is kept locally so that the CSS, you don't have to retrieve it every single time you click on a different part of the University of Michigan web page. Now, if you have Firebug installed in your Firefox browser, just go to a Firefox add-ons page and look for Firebug. It can actually show you dynamically all the different things that a page is requested in addition to the beginning HTML text. And you can use that to figure out, you can use that to see how long something takes, and each one is timed, and it's a really powerful thing to find the HTML pages it requests, the image files that it requests, the JavaScript files it requests, and the CSS it requests. And so you go into Firefox, and then you turn on the console, and then it shows you down here at the bottom. It grabbed the first page, and then it grabbed the CSS, then it grabbed that picture, this picture right here. It grabbed some more JavaScript. It grabbed this thing and that thing, and blah 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 blah. And so and you can see that it takes a certain amount of time for each one of these things, and you can see where it's actually pulling this information down from, and it really lets you reveal and get a sense of the intricacy of some of these web pages. But each of these lines here is a new request response cycle. So let's continue writing our first browser in Python. And so the first thing that we have to do is what we did in the last program, and that is import the socket library, create a socket library, and then connect ourselves to port 80 on a server across the network. Now it's like they've answered the phone. The socket exists. The socket creation creates it on your system. The connect makes the connection all the way to port 80 to their web server on the far end, and then you can make send calls and receive calls. It is a two-way socket. You can read and write simultaneously, actually. And so what we're going to do is the protocol says that it's going to listen, the far end is going to listen, and we have to send a command. So we are going to send a command, get space, again the rules are very strict, the document that we want, and another space, and then the protocol. We're talking HTTP 1.0 in this case, and then 2 new lines. And if you go back and look, this is exactly what you're supposed to do according to the RFC. So that sends a command to the server, the get command, and then the server does whatever it does, looks files up, does this, that, does the other thing. And at some point, it starts sending data back. And what we do to pull data out of the socket is we do a receive. We don't get back the data we sent. We get back the data it is sending in its send call. And so it's really 2 pipes. One is sort of an outgoing pipe for each of the 2 servers and an incoming pipe. And so we're going to write a little while loop, and we're going to say while true. And that's a little infinite loop, of course. And we are going to receive 512 characters at a time, up to 512 characters. We are going to receive in a data string. And if the socket is done and been finished and closed, then we'll see no data. The length of data will be less than 1. And then we'll do a break to get out of the loop. And if we get data, we'll print it, and then we'll go up and grab some more. So it'll run this loop a few times until it's retrieved all the information, and then at the end, when we got all the information, we tear down the socket, close it on our end, which closes it on the other end, and frees up scarce resources. And so that's a simple web browser. So let's see how this runs. Okay, and so if we run it, this is the output we get. Okay, and this is the loop that's running, and it might take a few calls or whatever, but it gets back a data. Now it's not getting it a line at a time, it's getting it with new lines in place, so each of the end of these lines has a new line in it. If you really wanted to split it in lines, you'd have to split it in lines. Okay, so we're getting it with new lines intact. Now the one thing that we're seeing here, it's a little bit new, is this purple stuff, and that's because we've asked for the HTTP 1.1 protocol, which sends a bunch of header information that's metadata about the document. Now this is different than the head area of the HTML document. This is actually, because not all data comes across the internet as HTML, this is metadata about the remaining data. And in this case, we're not even getting a HTML document back. We're getting a plain text document for this romeo.txt. The actual contents of the document are those 4 lines, the romeo.txt. And so if you type that URL, the romeo.txt URL, into a browser, you will only see this bit. But if you use Firefox, you can actually see these HTTP headers. And so we asked at a very low level to send everything, so it sent headers. It knows the difference between the headers and the text by a blank line. So it goes header, 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 as long as it needs to get a blank line, and then it's the body of everything. And that body actually could be an image for all that matter. Now, that's a real simple web browser, and we're making a socket call, and we're reading through a socket call. Now, we can make this a little simpler with an even more powerful library called URL-lib. Okay, and URL-lib is part of Python, and we can accomplish the same thing in far fewer lines of code by using URL-lib. And like everything in Python, we have an import statement to get access to that library, and it treats a URL like a file. We don't really care about the port anymore. We don't have to worry about sockets. We don't have to worry about connecting. That's exactly what's happening inside the URL library, but we're responsible for it. We just call urllib.urlopen and pass a URL. And at this point, what we get back is like a file handle. So this is a way of turning a URL on the internet into a file like object in Python. And at that point, we just write a for loop. And now the new lines and everything are being taken care of for us as well. So this is a line loop rather than a data loop. The socket original one was a data loop, not a line loop. And we simply print it out. So there we go. So if we run this program, this is what it looks like. So the loop's going to run. We're doing a strip because we will get new lines. It's breaking it into lines, but we're going to get new lines when it's all said and done. So we got to strip them. But that's the entire thing. Now, it's also smart enough to throw away the headers because it thinks we're just looking for the data, which is a completely reasonable assumption. So the headers aren't coming out, and so all we see are the 4 lines of text from Python for Informatics /code/romeo.txt. So this is also an extremely simple 4-line web browser written in Python. And so it really treats it like a file. So with URLlib, you can do anything that you would normally do with a file. And so we put these 2 lines, we import URLlib, we open it, and then we write one of our completely stock loops that's going to count the frequency of words in romeo.txt. We make a dictionary, we loop through for line in F hand, we split the line into pieces. For word in words, we update the counts using the standard dictionary, and we print it out. This code here is the same as if we had done a file open up here, but instead we've done a URL open. So Python has made this extremely easy for us. We can also just read web pages, and we read web pages like files, and now the lines matter, and so each time through the loop we're going to get a different line. Right, so we're reading page1.htm, we get line, 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 line. Okay, so that's a very simple loop to read through a web page, a line at a time. Now, if we wanted to look at the text, we could, and we could build a simple web crawler that would retrieve a page, then look for the links on that page, and then retrieve the other pages, the pages that our current page points to. All we have to do is we have to find a way to parse out those links. Now we could do that with regular expressions. We could do that with a bunch of string calls. But those would be kind of hard because there's a lot of different ways that you can make things look, and somebody's probably already written a bit of code that tears this apart. So if you think about it, this is what Google does. The simple Google is, retrieve a web page, read through the web page, look for links, and then retrieve the pages that are pointed to by that, and on and on and on and on. So this is a basic web crawler. We're starting to have the basics of a web crawler. So now we want to talk a little bit about how you parse HTML. Now, again, we could do this with regular expressions. We could do this with just low-level Python string primitives. This is also called web scraping. It's kind of like we're pretending to be a browser and scraping off the little tiny bit that is the HTML that comes back. So scraping's when a web program or script pretends it's a browser and issues browser-like requests and then parses the content and looks at it as if it were a human and then clicks virtually by retrieving documents. And if you do this enough, you spider the web or crawl the web is the common terms of doing this. So you got to be careful too. You can get in some trouble if you overdo this. So if you think about it, that we're taking advantage of the fact that there is an extremely simple protocol between the browser and the web server, the request response. And you send a get command and you get back HTML. We can basically in Python do the same thing with a URL open, do a get request and get back the HTML, except that we get it in a string instead of getting it in on our browser. Now, from the web server's perspective, it sort of hardly can tell the difference between a browser talking to it and a program talking to it. Now, they can figure subtle ways out, but on the whole, we just emulate what the browser does. And if the server's too smart, we can fake whatever the browser is doing if they get that nasty, that they want to do something to automated robots that are reading their data, and they can do that, and some do that. So why might you want to scrape data? Well, you might have a research project, and you can't get the raw data from some system, but you can hit the next button and hit the next button, but you do it virtually inside of a program. You also might find some system like blogger.com or something where you've run a blog for years and years and you want to switch to a different blogger and they won't give you the data back. You just write a program to pull all your blog posts and extract them. You might have an automated process that monitors a site for new information, or you really have a research project that's going to watch trends in Facebook Friends, where you look at some pages. Maybe I should use MySpace Friends because Facebook discourages this. And so you might be making some kind of highly specialized search engine. So there's a lot of controversy about scraping. Some sites get really upset about it, in particular those sites that are advertising driven and want users to see their ads in addition to their valuable information. Facebook and Google are examples of this. If you go build a search engine by sending search requests to Google and retrieving what they come back as the search request, and then make your own search engine, they will come down on you like a load of bricks, right? And you can in Google go search for Facebook scraping blog, and hear a bunch of people that are like, Facebook was mean to me, because in Facebook to scrape you have to log in on an account. So not only can they shut you down, but they knew who it was that was doing the abusing as an individual. And so, Facebook considers its information all theirs, Google thinks it's all theirs, and you just can't, just because it's technically possible to do it, doesn't mean that you have the legal right to do it. So you got to be really careful. You can get entire domains shut down. And so you got to read the terms of service, and you got to write your crawler to be reasonable sometimes. Facebook, explicitly says you're not allowed to do this unless you have explicit permission. So we got to parse HTML, and like I said, we could use regular expressions or string search or any other way, but there is a bit of wonderful free software called Beautiful Soup that has done this, and HTML can be so bad, and you might be able to parse simple and beautiful HTML a little bit with some strings or some regular expressions, but by the time it's all over, you will just spend the rest of your life trying to figure out what's going on. So the easier thing is to just download this Beautiful Soup. And the reason it's called Beautiful Soup is it's like a tag soup, a soup of tags. I mean, I don't know if that makes sense or not, but that is why they called it what they do. So you download this file from crummysoftware.com, and basically you put the beautifulsoup.py in the same folder as your Python code. There's a way to make it part of a library, but for now, just make it right in the same folder, and we're going to import it in a second. So here is how we write a simple Beautiful Soup program. So we're going to import URL lib, and from Beautiful Soup import star, this is just a different form of the import command. We're going to use a raw input to prompt the user for a URL. We're going to call URL open on that URL, and we're going to immediately call the read request. Now this time we're not actually going to get the handle back. We're telling it, not only do we want you to make the connection, we want you to read it all and give the entire page back to us as one big long string with new lines and all. Okay? And so what we get back here in HTML is an entire web page with less than HTML, less than head, everything from top to bottom. And we've told URL lib to just read it all. We don't want to write a loop to go through it ourselves because we got the whole HTML. Then it's really simple. We tell Beautiful Soup to parse it. Here's the HTML from the page. Start up Beautiful Soup, read through the entire thing, make a parsed version of the web page. And that comes back as a variable which we call traditionally soup. It's a soup of tags. It works a little bit like dictionary, and so I can go in and I can say, in this soup thing, now this is the syntax that Beautiful Soup basically says, say, you know what, I would like to retrieve a list of all the tags. I would like to retrieve from the soup, as it were, from the variable name soup, but we think of it as from the soup of all those tags that we just extracted using Beautiful Soup. Give me the anchor tags, the A tags. If you wanted the paragraph tags, you'd ask for the P tags. If you wanted the, UL tags, you'd ask for the UL tags. And so soup, parentheses, quote a quote says, give me all the A tags as a list of tags. So it's a list, so we have to write a for loop to go through it. So we're saying for tag in tags, and then each tag is like a Python dictionary of the HTML attributes. So if you think of an A tag, this is really ugly, href, equals, blah, 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 blah. This is an attribute, right? That's an HTML attribute. Style equals, href equals, source equals, all these things that are key value pairs in between the start of the tag and the end of the tag are what we can get. So we can say tag.get, which is a dictionary lookup in Python, give me the href. And if there is no href, remember the get, the second parameter of get is the default value. So give me none if there is no href. And so this loops through each of the tags in that document in order and then prints out the href attribute from that tag. And we didn't have to look for double quotes or single quotes or less thans or greater thans or anything, because Beautiful Soup did all that and made sort of a dictionary of dictionaries that we're reading through in these 3 lines. Okay? And so Beautiful Soup is doing a lot of work for us, right? It reads these things, it finds the A tags, it understands them, and then it extracts the href part and gives us only the href text. And so if we run this, urllinks.py, and we tell it to go read page1.htm, it prints out page2.htm. So here we are in about 9 lines of code. We have written the first bit of a web crawler that can retrieve a page and then loop through that page and find every link in the page. And it's a short step to then make a list of those links and then retrieve those links, and you've got yourself a web crawler. Enough of a web crawler to get yourself in trouble, probably. So, in summary, we've talked about the hypertext transfer protocol. We start with TCP/IP, which gives us clean, in-order, error-corrected sockets between applications. And we have application protocols like HTTP. We send the protocol is send the GET request, wait for what comes back. And HTTP is this elegantly simple protocol, so simple that we can do it by hand if we really want to. By sending the telnet and the GET command, it's very simple yet powerful and very extensible. And Python has a library for both sockets and URL lib and parsing HTML with